In this lesson, I'll show you 3 examples on how to graph linear absolute functions. The guidelines to doing this are shown here, and we'll refer back to these 3 steps as we do each question. The question reads, graph each of the following absolute functions where x is an element of all real numbers. Starting with A, we have the function f of x is equal to the absolute of x minus 3. According to step number 1, we have to find the x and y intercept of the positive version of the absolute expression. So here's the absolute expression, and we're going to find the x and y intercept if this were positive. So I'll rewrite this as y is equal to x minus 3. Now to find the x and y intercept, I will substitute x is equal to 0 and y is equal to 0. This will help me find the y-intercept, and this will help me find the x-intercept. So let's go ahead and do this. Substituting 0 into here, I end up with y is equal to negative 3. Therefore, my point is at 0 and negative 3. I'll plot that in a moment. Similarly, if I substitute 0 into here, I end up with 0 is equal to x minus 3. Bringing this minus 3 over to the other side, that's positive 3. Therefore, I have a point at 3 and 0. Now, let's go ahead and plot these 2 points. The first point is at 0 and negative 3. That means it's 3 units below the origin. And over here, it's 3 and 0. So our point will be right there. Of course, you can now go ahead and connect these 2 points. Now, in step number 2, they say, find the x and y intercept of the negative version of the absolute expression. So this time, and I'll show my work up here, this time x minus 3 will be placed in parentheses like this, and I'll put a factor of negative 1 in front of it. And I'm going to find the x and y intercept once again. So I have x is equal to 0 and y is equal to 0. Substituting 0 into x, I end up with y is equal to positive 3 this time. So my point is at 0 and positive 3. And if I substitute 0 into there, I'll end up again with x is equal to 3, leading me to the point 3 and 0. So I'm going to go ahead and plot these 2 points as well. 0 and positive 3 this time is up here, and 3 and 0 is at the same location as this. I'll put a line through these. As you can see, we have 2 lines. And in step number 3, they say, test a random x value before and after the point of intersection to find where the points don't exist. So this is our point of intersection, and what we're supposed to do is test x values to the left of this point and x values to the right of this point. In other words, take any random x value, substitute it into your absolute, and see if the output is positive or negative. And you'll find out that any number that you choose to the left of this point and any number that you choose to the right of this point will always produce a positive y. Therefore, any point along this tail end of the line and this tail end of the line do not exist. So we can go ahead and erase them. And what you see on your screen is the graph of this absolute function. Of course, we can analyze this further. Notice that there was a reflection about this point of intersection. So if you ever run into a situation where you have to graph, let's say, an expression that's an absolute, you can tell that once you find this point, everything below the point of intersection will not exist. So keep that in mind for question B. In question B, we have the function h of x is equal to the absolute of 2x plus 5. I'll start by finding the x and y intercept of the positive version. So I'll write down y is equal to 2x plus 5, substituting x is equal to 0 and y is equal to 0. And I'll also write down y is equal to negative 1, 2x plus 5, the negative version. Substituting 0 into here, I end up with y is equal to 5, so I have a point at 0 and positive 5. And substituting 0 into here, I end up with negative 5 over 2 is equal to x, which is equal to negative 2.5 and 0. I just made this into a decimal. I'll plot these 2 points. 0 and positive 5 is 1, 2, 3, 4, 5 up here. And negative 2.5 and 0 is to the left of the origin. It should be right there. Next, we'll do the same thing for this equation. So I'll set x is equal to 0 and y is equal to 0. Substituting 0 into here, I end up with y is equal to negative 1, 0 plus 5. That's negative 5. So my point will be at 0 and negative 5. That is 5 units below, right here. And substituting 0 into there, I should end up with the same x value as before, which is negative 2.5 and 0. So I'll connect this point and this point to form another line. There you go. And just as before, we're going to select random x values to the right of this point of intersection and to the left of this point of intersection. And you'll find out that the outputs that you get will all be positive. So these tail ends should not exist. I'll go ahead and erase them. Lastly, in question C, we have g of x is equal to the absolute of 1 minus 2x plus 2. I'll start by writing out the positive version and then the negative version. So the positive version should look like this. Bracket 1 minus 2x plus 2. And the negative version, y is equal to negative bracket 1 minus 2x plus 2. Of course, you don't need these parentheses. And if I substitute x is equal to 0 and y is equal to 0, let's see what happens. Substituting x is equal to 0, I end up with 1 plus 2, which is a point at 0 and 3. And if I substitute 0 into here, I'll end up with adding these two up. That's 3 bringing it over. Negative 3 is equal to negative 2x. Dividing both sides by negative 2 gives us 3 over 2 is equal to x. So another point at 3 over 2 and 0. Now let's go ahead and plot these points. 0 and 3 is 1, 2, 3 units up. And 3 over 2 is 1.5. That's 1.5 units to the right of the origin, which is right here. Let's connect these with a line. And that's what your line should look like. And once again, x is equal to 0, y is equal to 0. Setting this equal to 0, we end up with negative 1 plus 2. That's equal to 1. So 0 and 1 is one of our points. That's right here. And another point, if I set 0 as y, I'll get 0 is equal to negative 1 plus 2x plus 2. Combining negative 1 and 2, I end up with positive 1, bringing that over. Negative 1 over 2 is equal to x. That's negative 0.5. So our point is at negative 0.5 and 0, which is right here. Now putting a line through these 2 points, I should end up with another line that intersects the first at this point. And that appears to be at 0.5 and 2. Now what we're supposed to do is pick points to the left of 0.5 and to the right of 0.5, and you're going to find out that these y outputs will not exist. So let's go ahead and erase them. That's the graph for our absolute function. And those are 3 examples on how to graph linear absolute functions. In later videos, I'll show you how to graph quadratic absolute functions and those of higher degree. We'll see you soon.